I'm Anil Kumar. In this playlist of velocity applications, we'll try to understand the path of a moving object. And in the following examples, you will see how to calculate velocity from given speed and direction, how to find time when the two objects, moving objects, are closest to one another, and things like that. So I'd like you to understand these parameters first and then watch the rest of the videos to get good hold on this topic. The question here is, each of the following equations represents the path of a moving object. Distance units are meters and time is in seconds. Find for the object initial position, velocity and speed. So I've taken two examples. One of them, the very first one, is actually the vector equation. So this is the vector equation. And here we have given the equation in the form of parameters. So it is parametric equation. In general, when we talk about path of a moving object, we'll be writing the equation in the form P as x will be a function of time and y will also be a function of time, and that will be equal to initial position, which we may write as x0, y0. That represents initial position. I mean when t equals to 0, plus t times the velocity vector in x and y directions. I mean velocity vector in x and y direction. You get an idea, right? So this is the scalar multiple. And here we have velocity. Now t normally will be greater than or equal to 0 in most of the cases where t belongs to real numbers. So that is how in general we are going to treat these equations. Now let's see how to read initial position, velocity and speed from the given equation, right? So that's the whole idea. So first thing, let's look into the initial position for both the equations. So as I was saying, this part is from where the particle starts. If I substitute t equals to 0, then plus 0 makes that the position starts with minus 4, 3. So the initial position, if I write in the terms of position vector, will be given as minus 4, 3. In the parametric form, if I write t equals to 0, for x I get 0 and for y I get 3. So here the position will be 0, 3, correct? I could write this as 0 plus 60. You get an idea. So that is how we can just see it. Now velocity vector is right there. This is your velocity vector. So the velocity is given as 12 minus 5. Here it is 6, 2. Speed is magnitude of velocity, right? Speed is magnitude of velocity. So we'll find the magnitude as square root of 12 square plus minus 5 square. So calculate this. And here it will be square root of 6 square plus 2 square. Calculate this, right? So that is how you're going to find the speed. So let's calculate. So we have square root of 12 square plus 5 square, which is 13. And in this case, it is square root of 6 square plus 2 square, which is 2 square root 10. Now we have to include the units. Meters per second, since we are given distance in meters and time in seconds, correct? So the units will be meters per second, and we'll say the initial positions are in meters and velocities are in meters per second. So I hope with this example you understand the very basic equation. Now in the following examples we will say if the speed is 13 meters per second and the direction is something like this, then what is the velocity vector, right? So that will be your question in the next video. Let me write down the question for you. Here we'll say if speed equals to, let me just write one number here, 7, and direction is, let's say, 2 minus 3, find velocity vector. Okay, so that is the type of question we'll take up next, and then we'll take more complicated examples based on our applications in relating displacement, position, velocity, and time. Thank you and all the best.